Okay, so we're going to talk about adding and subtracting rational expressions. So anytime you add two fractions, you have to have a common denominator. It really doesn't matter if you've just got 1/2 and 3/4. You got to have a common denominator. So that's the same with these rational expressions. Notice that I have 3x minus 4 over x plus 3 plus 4x plus 4 over x plus 3. I have a common denominator of x plus 3. So that means on top I'm just going to combine like terms, 3x and 4x, that makes 7x. Negative 4 and positive 4 are going to cancel, and then I keep that common denominator of x plus 3. The other thing I have to think about are any values that would cause a problem. So for instance, since I have an x plus 3 in the denominator, I would set that denominator equal to 0, solve for x. So that shows me that x cannot be equal to negative 3, because if it were, negative 3 plus 3 would give me a 0 in my denominator, and we know that that is not possible. So we always want to check for those issues. Okay. Number 2, I have 6x plus 5 over x squared minus 3 plus 3x minus 1 over x squared minus 3. Again, I have a common denominator of x squared minus 3. I will just add the tops together. 6x plus 3x is 9x. 5 and negative 1 will give me 4. And that's all over my common denominator of x squared minus 3. So again, I have to think about what x cannot be. So I will set that denominator equal to 0 and solve for x. So I'll add 3. That's going to leave me with x squared equals 3. And then to get rid of that square, I have to square root. And don't forget that you also have a positive and a negative value. So that would be x is equal to plus or minus the square root of 3. So I know that x cannot be the positive or the negative root of 3. All right, let's talk about one that's subtracting. Subtracting is just like adding, only you have to think a little bit. Since I have more than one term after my negative right here, I need to distribute that. So this first one, it stays just like it is, 2x minus 1 over x squared plus 2. But then I'm going to distribute this negative. So that's going to give me plus a negative 4x minus 4. Notice I do have the same denominator of x squared plus 2, so I'll just combine the tops again. 2x and negative 4x are going to give me negative 2x, and negative 4 and negative 1 will give me negative 5, all over my common denominator of x squared plus 2. So I want you to think about this for just a minute. If we're trying to find values for which the bottom would be a 0, you have to think about this. First off, if you set that equal to 0 and solve for x, this is what's going to happen. You're going to get x squared equals negative 2, and when I square root that, anytime you square root a negative, you're going to end up with an imaginary number. And when you do that, that should be a big hint that there are no real numbers that will give you a 0. And think about it this way. Any number that I plug in and square, it's going to become positive. So even if I square negative 2, that's going to be a positive 4. And then I'm going to add 2 to it. So even if I squared 0, 0 squared is 0 plus 2 is 2. I'm never going to get 0 because no matter what, I always have a positive number, and then I'm going to add 2 to it. So I don't have any values that are going to cause a problem for me at all. So if you get a square root of a negative, that's a big hint that, hey, you don't have a problem over here. Alright, so let's talk about LCM, least common multiple. That means it's the smallest number that both terms will go into. So for instance, the least common multiple between 2 and 3 would be 6. That's the smallest number that both 2 and 3 will divide into. Alright, and then with variables, it's easy. You take the biggest one. 3 and 5 will both go into the 5. Alright, and with the y's, 4 and 3 will both go into the 4. Alright, so it's kind of like greatest common factor, but opposite almost. So this would be x to the 5th and y to the 4th. Easy way to remember, it's always going to be the bigger exponent. Okay, so your main problem is going to be this the front numbers. And it's not always that you multiply them. In this case, 2 times 3 is 6. Alright, so let's talk about 4x cubed y to the 7th and 3x to the 5th y to the 4th. The smallest number that both 4 and 3 will go into is 12. The smallest thing that both x cubed and x to the 5th will go into is x to the 5th. And the smallest thing that both y to the 7th and y to the 4th will go into is y to the 7th. Alright? And this last one, the smallest thing that both 4 and 6 will go into is 12. Notice on this one you can't just multiply the two. Alright? The smallest thing that x squared and x to the 4th will go into is x to the 4th. And then between y cubed and y to the 5th, that will be y to the 5th. Alright, so those are some easier examples. Now we're going to talk about trinomials and their least common multiple. Alright, so you've already done things like this in previous courses. This is something that's kind of new to you. We have not done least common multiples of trinomials. So the thing is that you want to factor each of them. So let's factor this one right here. So I have a trinomial. I'm going to factor that. I have a minus in the back. That means 1 plus and 1 minus. I'll have to have an x in the front. And then two numbers that multiply to make 4 and subtract to make 3 would be 4 and 1. And since there's a plus in front, that means the 4 is bigger. We'll go with the plus. And then I'm going to go ahead and factor this one, and I'm going to do it right below. Okay? I'll do it in orange. So I have a plus and back, which means 2 of what's in the front. So I have 2 minus signs. I'm going to have an x and an x. And what multiplies to make 2, it adds to make 3 would be 2 and 1. Since I have the same sign, I don't have to worry about that. Okay? So you're going to compare these two. And if they have a common factor, then you're going to write that down once. So they have a common factor of x minus 1. And if you would, cross those out so that you know you've already got that common factor. But then they don't have any other common factors. So whatever's left over, you're just going to write directly behind it. So I've got x plus 4, and I've got x minus 2. If I were to multiply that out, that would be my least common multiple. So it's pretty easy. You find their common factors, write that down once. So this is what they have in common, and then these are the things they don't have in common, so you have to tack those on behind and multiply them. Alright, let's do another one. So here I have the difference of two squares, so I will factor that. Remember, with the difference of two squares, it's always a plus and a minus. You take the square root of the front and put that in front, and the square root of the back and put that in the back. And then we're going to factor this one. I have a trinomial, so it factors into 2. A plus and back means 2 of what's in front, so that'll be 2 plus signs. I have an x squared, so I'll have an x and an x. And two things that multiply to make 6 and add to make 5 would be 3 and 2. So I'm going to look at these two and see if they have any common factors. Well, I see that they both have an x plus 2, so that's something that they have in common. So I'm going to mark those out so I'm not done with those. And then I see that they have two other factors that they do not have in common. So I'll write down the x plus 3 directly behind that, and the x minus 2. It doesn't matter which order you put them in. And I won't make you multiply those out. Alright, so now let's take a look at number 9. I have two trinomials. Let's do this one first. Alright, so a minus in the back means 1 plus 1 minus. I'll have an x and an x. And what multiplies to make 3 and subtracts to make 2 would be 3 and 1. Since there's a minus in front, 3 will go with the minus. Then I'll factor this one right below it. I like to stack them. A little bit easier to see. Minus and back means a plus and a minus. I have an x squared, so I'll go x and x. And what multiplies to make 6 and subtracts to make 1, that would be 3 and 2. Since there's a minus in front, the 3 will go with the minus, and the 2 will go with the plus. So now I look to see what they have in common. They both have an x minus 3. So I write that one time. These two are not in common, so I'm going to tack those onto the back. So I have x plus 1 and x plus 2. And I have found my least common multiple. Now, the reason that this is important is because when I have to find a common denominator, I need to know what the smallest thing that they both go into is. Alright, so let's talk about adding some rational expressions. Notice that I no longer have a common denominator. So, when I see that one of my denominators is a trinomial, I want to attempt to factor that. Because in order to put these two together, I have to have a common denominator. So let's factor the bottom. Plus and back means 2 of what's in front. I will have x and x. And what multiplies to make 2 and adds to make 3 would be 2 and 1. And over here, I can't factor that denominator, so we'll just leave it as is. Now, if you will notice, I've got x plus 1 as a factor over here, and I have an x plus 1 and an x plus 2 over here. So what I'm going to do is I notice that we share a common factor of x plus 1. The only thing that I don't have on this side that would make this a common denominator is the x plus 2. So if I were to multiply top and bottom by x plus 2, that's going to help me out. So I have x minus 1 all over x plus 2, x plus 1. Oh, I apologize, I wrote the wrong number right here. That's supposed to be a 2. Okay, over here I need to multiply, so I have x times x is x squared, and x times 2 is 2x, all over x plus 1 times x plus 2. Leave the bottom separated, don't put it together. So now if you notice what that did for me is I now have the same two factors on top and bottom. Now I can add these two together. So I'm going to kill two birds with one stone. Since I have adding here, I'll go ahead and do in standard form. I have an x squared. I have a 1x and a 2x. That's going to give me 3x. And then I've got minus 1 all over x plus 2, x plus 1. I realize that these are in two different orders, but it really doesn't matter. 2 times 3 is the same thing as 3 times 2. So, with that being said, then you should see if you can factor the top, because if you can factor the top, then you might be able to cancel out some factors at the bottom. But there is nothing that's going to multiply to make 1 and subtract to make 3, so there's no point in trying to factor this. Alright? And I'm trying to decide if I'll let you leave your answers like that or not. Okay, I'll let you leave these separated. You can give me this, or if you want to multiply it back out, you should get what you had in the beginning. Okay, so I'll take this answer, or x squared plus 3x minus 1 over these two things multiplied, which would be that. So really it's not any extra work for you, but it does look a little cleaner. Alright, the other thing we have to think about is what x cannot be. So we always use our factors from the denominator. So all of the factors that we have at the bottom would be the x plus 2 and the x minus 1. So if I were to set those equal to 0 and solve for x, I would get negative 2 and negative 1. So x cannot be negative 2 and x cannot be negative 1. So I will take either of those, but you definitely have to have the solutions that will not satisfy for x. Alright, so let's take a look at a subtraction problem. So remember I told you when you have a subtraction problem, always start by distributing that negative through the top. So the first fraction will stay the same. This is going to be plus a negative x and a negative 4. Now, in order to put these two together, I have to have a common denominator. If you can factor a denominator, then you need to do so. So that's what we're going to do. We have difference of two squares over here. So I'm going to factor that. It always factors into two binomials with a plus and a minus, x and x, and the square root of 4 is 2. Now I have to decide, in order to get the same denominator, I already have an x plus 2 here, and I have an x plus 2 here. That means that over here, all I need is to multiply by the x minus 2. So I'm going to do that, top and bottom. So I'm going to simplify this. I've got 2x squared minus 16 all over x plus 2, x minus 2, plus, I have two things times two things, so it's probably helpful to enclose this in parentheses, and then that makes you realize that you're going to have to distribute. So a negative x times x is negative x squared. Negative x times negative 2 is positive 2x. Negative 4 times x is negative 4x. And negative 4 times negative 2 is positive 8. Okay, so that's all over the x plus 2 and then times x minus 2. So now I have the same denominator, which means I can combine these two fractions together. So I'll start with the x squared. 2x squared minus 1x squared is just x squared. Then I have a 2x minus 4x, that's negative 2x. And negative 16 and positive 8 make negative 8 all over x plus 2, x minus 2. So now we need to see if we can factor the top. There are two numbers that will multiply to make 8 and subtract to make 2. So we'll go ahead and factor that. Plus and a minus, x and x. And the two numbers that will multiply to make 8 and subtract to make 2 are 4 and 2. Since there's a minus in front, the 4 will go with the minus, and the 2 will go with the plus. And if you'll kind of notice, this is exactly what you did in the previous section. So we notice that we have common factor, x plus 2. So that leaves us with x minus 4 on top, x minus 2 on bottom. And we have to think about what x cannot be. Well, I had an x plus 2 and an x minus 2 on bottom. So if I were to set those equal to 0, x cannot be plus or minus 2. Alright, so we're going to take this and go a little bit farther and talk about complex fractions. So here's the deal. You cannot divide two things when there are more than one term on the top. So for instance, see how I have two fractions on the top of this big fraction, and I have one fraction on the bottom? I need for this to be 1. So what I'm going to do is, I'm going to take this whole top and I'm going to simplify it first. So let's take it out to the side. In order to put these two together, I have to have a common denominator. Well, this side has an x and this side has a 4. So in other words, the smallest thing that both x and 4 will go into is 4x. So on this side, I'm going to have to multiply by 4. And on this side, I'm going to have to multiply by x. So if I simplify that, 4 times 2 is 8, over 4 times x is 4x, plus x times x is x squared, over 4 times x. See how I now have a common denominator of 4x? So I can put these together. I have an x squared plus an 8 all over 4x. So I took this and I simplified it into one fraction. So now, put it back in. So you've got x squared plus 8 over 4x divided by this bottom that you already had. Now, this is exactly what you did in the last section. Only here's the deal. Instead of writing it this divided by something, they've put 1 over the top. And remember, when you divide two fractions, the way you simplify that is you just multiply by the reciprocal. So like some people call it keep, change, flip. You keep the top fraction, change division to multiplication, and flip the bottom. I just prefer to say multiply by the reciprocal. So that means I keep this top fraction, change division to multiplication, and then I'm going to flip this one, just multiplying by the reciprocal. Now, at this point, if you could factor something, then you would factor. None of these can be factored. If you could cancel something out, you do. So in other words, I have an x here and an x here. I can cancel those. Alright, so then all I have left is x squared plus 8 on top. And then on bottom, I need to distribute the 4 with the x plus 1. So that would give me 4x plus 4. And on these, I'm going to assume that all values of x are defined. Alright, let's do a couple more examples. So number 13. I have a fraction on top. I have a fraction on bottom. Notice this one is not split into two separate fractions. It's just one. So I'll keep the top fraction. I will change division to multiplication, and I'll flip the bottom fraction. Now, if I can factor something, I do. I cannot factor x plus 1, x minus 1, or x, but I do see that this is the difference of two squares, so I will factor it. So I have a plus, a minus, an x, and the square root of 1 is 1. So I have an x plus 1 that will cancel, leaving me with a 1, an x minus 1 that will cancel, leaving me with a 1. So all that's left is 1 times 1 on top, and on bottom, just the x. So we just have 1 over x. Let's do one more. Notice again, this is one where I have two separate fractions on the top and I have one on bottom. So I have to combine this into one fraction before I can move on. So let's pull it out to the side. Now I notice that if I want to combine these, I have to have a common factor. Well, they both have an x, but this one doesn't have a 2. So if I multiply by 2, that gives me 2 over 2x plus 1 over 2x. Now I have a common denominator. I can combine like terms. 2 and 1 make 3 over 2x. That's ready to go back in to the top. So remember, all you've done is you've just taken this and simplified it into one fraction. So that's all over x plus 4 divided by x minus 2. Now I have a fraction divided by a fraction. So I will keep the top fraction and multiply it by the reciprocal of the bottom. So you're just flipping it. So if you can factor anything you do, I cannot. I do not have any common factors. So I just multiply this together. 3 times x is 3x. 3 times negative 2 is negative 6. 2x times x is 2x squared. And 2x times 4 is 8x. Alright, I will take this answer, or I'll even take 3 times x minus 2 over 2x times x plus 4. Alright, that's all I've got for you today.